Hello everyone, welcome to our lesson. We're going to look at the theorem that involves the tangent and the radius, or the tangent and the diameter. Right, what does it say? It says that the tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. The tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. So now you have the tangent AB here, and then it is perpendicular to this radius at the point of contact. That means the angle OCB there is 90 degrees. You see that? So the tangent to a circle is perpendicular to the radius or diameter of the circle at what? At the point of contact. That's the theorem we're talking about. Right. Now, the reason you write, you can say tangent perpendicular to radius or tangent perpendicular to diameter. Okay. Right. The converse now says, if a line is drawn perpendicular to the radius or diameter at the point where the radius or diameter meets the circle, then the line is a tangent to the circle. Like now we're drawing this line here, AB, which is perpendicular to the radius or diameter. Then AB is what? Then AB is the tangent. That's the converse theorem of that. And then the reason you write, you can say line perpendicular to radius, or you can say converse of tan perpendicular to radius, or converse tan perpendicular to diameter. Right, let's go straight to our first question. Right, O is the center of the circle, PT is a tangent of the circle, A is a point on the circle, and it is where the tangent is in contact with the radius. Solve for X. I want you to pause the lesson here and try to solve for X. Let's try. Right, remember that you can learn at your own pace here. You can even rewind the video if there's something you missed. Okay, don't rush. Take your time and pause the video, and then go back also if there's something that you think you've missed. Okay, right now, and you can play the video as many times as you want. Right now, so we say we have angle A2 there. Do you see angle A2? A2 is equals to 90 degrees. Angle A2 is equals to 90 degrees. Why is angle A2 equal to 90 degrees? Because here tangent is, because we're told that PT is the tangent. Tangent is perpendicular to radius. Tangent is perpendicular to radius. And then now we have the interior angle of triangle AOT. So in triangle AOT, we can see that A2 plus angle O plus angle T is equals to 180 degrees, because this is angle sum in triangle, meaning that A2 we got that is 90, and then angle O there is 47 degrees. Mean angle T, that's the X we are looking for, is equals to 180 degrees. You see that? And then we can transpose our 90 degrees and what? And 47 degrees. What do we get? We get that X is equals to 43 degrees. Done. We've managed to solve for X there. Okay? Right. Now, let's go to the next question. This is the question. Please go through it, read the information, and try it. Let's try. Right, welcome back. Right, it says A, B, and C are points on the circumference of the circle with center O. B1 is 60 degrees, PT is the tangent to the circle, BC is the diameter, and determine the size of X, Y, and Z. So we can easily find these angles using the Chord theorem, but because we haven't done the Chord theorem, I'll stick to the theorems that we have done, which is the theorem that involves the tangent in the radius or the tangent in the diameter. But soon after this, I'll just show you how you could have used what? The Chord theorem. But some of you that know what the Chord theorem is, you could have done that and you can easily get your answers, okay? Right, now, we have angle PBO. Do you see angle PBO? This is angle PBO, right? Angle PBO is equals to what? Is equals to 90 degrees. Why? Because tangent is perpendicular to diameter. Tangent is perpendicular to diameter, right? Okay, and then if this is 90 degrees, then we can easily find B2 there, because B2, it means if we add B2 and B1, we must get 90 degrees. So x plus 60 degrees is equals to 90 degrees, meaning that x is equals to what? X is equals to 30 degrees. So meaning that this angle here is 30 degrees. Okay, right. Can we find angle y? Yes, we can easily find angle y. What is the size of angle y? It is 90 degrees. Why is y 90 degrees? Why is y 90 degrees? So because it is an angle in the semicircle. Is angle subtended by what? Subtended by diameter. You see, BC is diameter, so it's subtending that angle there. Right, and then we can easily find angle Z because we have triangle ABC there. We have triangle ABC. We can say in triangle ABC, right, we can find these angles because these are angles in what? The interior angles of a triangle. So we can say 90 for the y here plus 30 degrees plus z is equals to 180 degrees, which is angle sum in triangle. Angle sum in triangle. Then we can say angle z here. No, we don't need that. Angle z here is equals to, let me just erase that because we don't need that, the head there for this. Okay, yes, perfect. So angle z is equals to 180 minus 90 minus 30, which is 60 degrees. So angle z is 60 degrees. Done. Okay, right. Now let me show you how you could have used the tan chord theorem. So this is the angle between the tangent and the chord. So an angle is subtended in the alternate segment. This is the z. So meaning that this angle here is 60 degrees. You see that? And then this angle here is subtended by the diameter. So is what? Is 90 degrees. So this one is 90 degrees here. It's 90 degrees. And then meaning that 60 plus 90 plus x must give us 180, meaning that this one is 30 degrees. You see that? Angle is in a triangle. So you could have used tan chord theorem and the angle in the semicircle and also sum of interior angles in a triangle. Then you get all your variables. Okay, I'm going to give you the next question, then we continue after that. Let's go to the next question. Right, this is our last question. Let's try it, read through the information and try to answer this question. Right, welcome back. I hope you managed to try or you managed to get the correct answers. Right, let's do it together. Right, A, B, and C are points on the circumference of the circle with center O1 is 120 degrees. PT is the tangent to the circle, and then PT is perpendicular. PT is parallel to BC. Determine the size of X, Y, and Z. Again, we can use the tan chord theorem here. It will be very easy to use the tan chord theorem, but I'm going to use what? This theorem that involves the tangent and the radius. Okay, so now if you check here, we have OA is equals to OB because this is their radii. Okay, radii. So meaning that angle A2 is equals to angle B1. Angle A2 is equal to angle B1 because these are angles opposite equal sides. These are angles opposite equal sides. Right, okay. So it means here we can find this angle A2 by just saying that A2 is equals to 180 degrees minus 120 degrees divided by 2. Okay, because this is angle sum in triangle. right? Because B1 and B2 are just, B1 and A2 are just the same thing. And then we get that A2 is equals to 30 degrees. So A2 is equal to 30 degrees. See that? Okay. But now, what can you say about angle PAO? PAO. What can you say about angle PAO? Is equals to 90 degrees? Yes, it is equal to 90 degrees. Why? Because we have tangent perpendicular to radius. Okay, the tangent radius there, AO, is the radius. Okay, so now meaning that x plus 30 degrees is equal to 90 degrees. And then we can find that x is equals to 60 degrees. You see that? Okay, right. And then we can, now we can write 60 degrees here. This is 60 degrees. You see that? And then you can see that y is also 60 degrees. But let me not use that. I'm going to use this angle here at the center, angle at the center, this angle. Okay, see this one? So we're going to say y is equals to 60 degrees because angle at center, angle at center equals 2 times angle at circumference. Okay, angle at center is 2 times angle at the circumference. And then now if you check, we have parallel lines PT and BC. So meaning that Z also is what? 60 degrees. Why? Because they're of the alternate angles. Okay, so Z and Y are alternate angles. So Z is equals to 60 degrees because alternate angles equal. Since PT is parallel to BC. PT is parallel to BC. So now that's why Z is also 60 degrees. Done. Okay, but we could have used the Chord theorem. Let me just show you here. We could have said now this is the angle at the center, this is the angle at the circumference, this is 60 degrees. And then this angle here and this angle here, we can use Chord theorem. You see that? We can use Chord theorem and get our 60 degrees. And then this angle here, and then this angle, sorry, my line is not, this angle here, the Z, these are alternate angles. See that? These are alternate angles. So it means Z is also 60 degrees. You see that? You could have done that. But we're going to do that in our next lesson. We're going to be doing the Chord theorem in our next lesson. Okay, right. Thank you very much. We are done. We are going to meet in our next lesson. Kindly subscribe to our channel and continue benefiting from these lessons and prepare for your examinations. Let's meet in our next lesson. Goodbye.